Last class, it's been a while since we talked about math, by the way, but on Monday before we took test 3, we went over this set of notes about hypothesis testing, right? So we did an experiment. We said that the experiment usually has a null hypothesis and an alternate hypothesis. We get this information, and based on like what happens in reality, we either fail to reject the null hypothesis or we reject the null hypothesis, right? So we did some practice on like fail to reject, oh my gosh, reject the null hypothesis. We talked about how to write our hypotheses using these weird symbols. And then we talked about how to write our conclusions based on like if we reject, fail to reject, so on. Then we talked about errors really quickly, which we'll talk about a little bit later, but that's kind of the main gist of what we did. Now, you were probably really confused in that section because it's just a lot of like esoteric things like all mixed together. I think this section will help you kind of understand exactly what's going on in that section. So let's go ahead and talk about hypothesis testing for a population mean when sigma is known. Okay, just like confidence intervals, we're going to have questions that give us problems where we know sigma, and then there's going to be problems where we don't know sigma. This section is just where we know sigma. The other section is where we're going to be given S instead of sigma, right? Okay. So in these questions, we're going to learn how to use this thing called the p-value method. But before we do that, we're going to be given like a really long paragraph of a question. And in this paragraph, we can actually come up with a few things. We can come up with our null hypothesis, which if you don't remember has an H0 as a symbol, right? After H0, we put a little colon. We're always talking about what mu is, and we're saying that mu is equal to some sort of number. Okay, this is always what the null hypothesis looks like. So it's like saying, okay, before we start, I think that mu is equal to 2 or 7 or 15. Okay, next we have an alternate hypothesis, which is kind of like the other thing that can happen, right? Now, does anyone remember the symbol for the alternate hypothesis? It's H, but what's on the bottom? 1, right? It's kind of like if you think about binary numbers, have you ever heard of those? 1 is like the opposite of 0. Okay, the alternate hypothesis has all the same stuff as the null hypothesis. We're still talking about the mean. We still have a number. The only difference is that the alternate hypothesis has either a less than sign, a greater than sign, or a not equal to sign. Okay, so that's really the only other thing that can happen. Okay. Next, questions in this section will give you a few symbols. It'll tell you the population standard deviation. Does anyone remember the symbol for that? Is it S or is it sigma? Sigma, perfect. Okay. We're going to conduct an experiment, and in that experiment, we're going to have a sample size of n, right? And from that experiment, we're also going to know the sample mean, which is X bar. Okay, that's all the information we have. Okay, basically what we're going to do is, since we have our hypothesis that mu is equal to a number, well, what happens in real life is we're going to get what X bar is, and we have to see, okay, how close is X bar to mu in our hypothesis? Do we have enough information to reject HO, or can we just kind of like say that there's not enough evidence to do that? Okay, now how are we going to do that? We're going to use this thing called the p-value. Okay, now in this class, I'm not going to go too much into like what the p-value is, mainly because, well, we have Minitab to like calculate it for us, so we don't really need to know. But if you're ever curious, it's just like the probability that your population mean will be greater than or equal to like the value that you have in your experimental mean, so X bar. We can talk about that in my office hours if you want to know more. But honestly, we have really good tools and technology to find this p-value, so I'm not going to delve into it in this class. We will, however, use the central limit theorem to find the p-value, okay? Now, the smaller the p-value is, the stronger evidence we can say to reject the null hypothesis. So if H is really small, we can reject the null hypothesis. If H is kind of big, then we can't reject the null hypothesis, okay? And that might be confusing at first. I think doing some examples will help you see what's actually going on, okay? Now you're probably wondering, okay, I know that P has to be small to reject the null hypothesis, but how small does P have to be, okay? And the answer is, well, it depends, okay? Your question in these questions are going to give you something called the significance level, okay? The significance level is alpha, okay? So alpha is the significance level. Okay. The significance level is always given to you in the problem. So you don't have to figure out what it is. It's just given to you. Okay. Now, what we're going to do is we're going to do some work and we're going to find this value P. If P is less than alpha, we reject the null hypothesis. If P is greater than alpha, we do not reject the null hypothesis. Okay. So I know this sounds kind of confusing at first, but once we piece everything together, I promise you it's going to make a lot of sense. Let's just talk about rejecting and failing to reject. By the way, do not reject null hypothesis. It's the same as say fail to reject the null hypothesis. Okay. And let's just do some practice with just this concept. Okay. Now, let's say we have a p-value that was 0.0122. I want to know if I reject the null hypothesis at this alpha level, significance level, right? Now, personally, I know a lot of you can do this in your head, but for me, I cannot compare two numbers, especially if they're small, if I don't write them side by side, okay? So I'm going to put p on the left. I'm going to put alpha on the right, okay? And while p is 0.0122, alpha is 0.05. And for me, it's just so much easier to determine which one is bigger when they're right next to each other, instead of like looking at the question and trying to see which one is bigger. Which one is bigger, p or alpha? Alpha, right? If you take a look at the second decimal place, 5 is bigger than 1, right? So alpha is definitely bigger than p, which means p is like less than or equal to alpha, using the terminology above. Okay. So if p is less than or equal to alpha, do we reject or fail to reject? Reject, right? If p is less than alpha, reject the null hypothesis. Reject HO. Okay. So that's really all you have to do if you know what the p-value is. Why don't I give you like, I don't know, 30 seconds to do example number 2. Same sort of deal, and we'll come back. I have been bombarded by emails today. All right, let's come back together. Personally, I like to write p and alpha next to each other. That's just my personal preference. Maybe it's just because my brain like cannot tell the difference between bigger numbers and smaller numbers. P is still 0.0122, right? Alpha is 0.01 now. Which one's bigger now, alpha or p? P, right? So p is bigger than alpha. Do we reject or fail to reject? Fail to reject. Fail to reject the null hypothesis. Okay. And that's basically what you do. Okay. So far we've talked about how to write our null and alternate hypotheses. We know how to write the conclusion. Now we know how to come up with a conclusion, knowing what p is, right? The only thing we have to know now is how do we find what p is, right? That's the big question. Okay. Now, earlier on when this class was taught, basically like you had to do a bunch of math to figure it out. Now that we have technology, it becomes super easy. Okay. And basically what we have is we have a bunch of steps that involve Minitab. Okay. I know the steps look crazy right now, but I promise you, like once you do it once or twice, it's super easy to remember what to do. Okay, so we have steps for hypothesis testing. Step 1 is to state your assumptions. Okay, now since the central limit theorem has something to do with this whole p-value thing, we have to determine if, well, first the sample size is large, right? And if that's not true, if the population is normally distributed, right? So that's kind of just our normal given thing. The other question is if sigma is given to us. The reason I'm asking this is because in the next section, sigma is not going to be given to us. So we're going to do something different, just like confidence intervals. Step 2, you're going to state your null and alternate hypotheses. This is what we did in the last set of notes. We just kind of learned how to write HO and H1. Step 3, you need to calculate this thing called the confidence level. This is a formula that you do unfortunately have to memorize, okay? So memorize this, okay? You basically take alpha, you subtract it from 1, and you multiply it by 100. This is the confidence level. It's really not big to memorize it now because we're going to be using that formula in pretty much every single section after this. So don't really worry about it now. You'll memorize it by the end of the class. Next is Minitab. You're going to click a bunch of stuff. I'll show you what to do when we do an actual example because I think it's just way easier to do that. Step 5, you're going to determine if you reject or fail to reject the null hypothesis, comparing p to alpha, right? Okay. Step 6, you're going to write your conclusion. You're going to start with we conclude or not enough evidence. You always end up with the alternate hypothesis. This is what we did in the last section as well. Okay, let's just piece this all together and do an actual question, okay? All right, now this example, these examples get very, very long. It kind of hurts just looking at it, but I promise you, if you write down all the information before you do the problem, it becomes 10 times easier. Okay. So example one, we're talking about the mean height of adult men in the US, and it says that this mean is equal to 70 inches. Okay. Now, 70 is a mean. Do you think it's the population or the sample mean? Not, okay, I feel like we're all saying sample, which I mean, I kind of led you to that because with confidence interval questions, you're never given the population mean, right? Now, hypothesis testing, you actually are given like it not really is the population mean, but it's kind of like a hypothesis as to what it might be, if that makes sense, or something that it was before. So this is actually a population mean. Okay. Now, a couple of reasons. Okay. First of all, we haven't talked about a sample yet, right? We didn't say we took a sample of this many people. We didn't poll people. There's no sample at this point in the paragraph, right? So that's kind of my hint that, okay, since there's no sample yet, this has to be the population mean, right? The other thing that's kind of a hint here is usually it'll kind of tell you like the mean of all adult men in the US. Like that's a large category of people. It's not like we sampled every single person in the US, right? So that's kind of my other hint. This is the population mean. Does that kind of make sense? I kind of led you to say sample since it was always sample mean before, but this is actually the population mean, mu equals 7. Okay, then it says with a standard deviation of 3 inches. Now it doesn't tell you if it's the population or the sample. Which one is this, population or sample? Population, right? If it's in the same sentence as what we're talking about, as we're talking about the population, right? It has to be the population. Also, we haven't talked about the sample yet. So if the sample isn't introduced, then it's got to be the population, right? Okay. Now we have a sociologist. The sociologist believes that taller men might be more likely to be promoted, so that the mean might be greater. We took a simple random sample of 100 male business executives. That's N, right? And that sample has a mean height of 70.3. Now, do you see the difference between this being the sample mean and the other one being the population mean? Yeah, right. We took the sample and then from that we got a mean. X bar is 70.3. Okay. Assume that the standard deviation is sigma equals 3. We already wrote that down, so I'm not going to write it down again. We want to conclude if male business executives are taller on average at the alpha equals 0.05 level. So alpha equals 0.05. Okay. So I wrote down all the information. This was really helpful, especially because sometimes when you're doing these questions, it's just so hard to go back and forth between the big paragraph and writing down your numbers. It's just a little crazy. Okay. Let's do step 1, which is stating our assumptions. This one's pretty easy because we did this before, right? Is sigma given to us? Yeah, right. Sigma's 3. It's given to us. Sigma is given. Is our population size bigger than 30? Yeah, right. 100 is bigger than 30. So we're good. We don't even have to see if the population's normal. Population sample's big enough, so we're good. Okay. Next is writing the null and alternate hypotheses. I know that this has been a while since Monday. We introduced this on Monday. I taught you how to do this, but it's been a week. I understand if we're not there yet. So let me lead you through this. The null hypothesis is always H0, right? After H0, we'll put a colon, and we're always going to talk about the mean. And in particular, the mean being equal to some sort of number, okay? Now, it's really nice that I wrote down all my information here because we actually have 2 means in the questions. Well, what is mu equal to when I wrote it down? 70, right? So it's good to write it down before. So now you don't have to go out and be like, okay, which one is the population mean? What are we talking about? It's literally written down for us. We just have to fill it in. Okay. The alternate hypothesis, or H1, has mu 70. Everything stays the same except for the symbol in between, right? Now, my biggest hint for you to figure out what the symbol is I usually look at the very last sentence in the paragraph. The last sentence of the paragraph tells us what we're interested in, okay? So it says, can we conclude that the male business executives are taller on average than the general male population? So if it's taller, do you think we're greater than, less than, not equal to? Greater than, right? So since we say taller, I'll circle that, mu is bigger than 70. Okay, so to find the alternate hypothesis, just look at the last sentence. It usually tells you like, you'll look for like smaller than, taller than, wider than, more narrow. greater, less, I can't even think of any other words like wider. I already said that. I don't know, anything that says that something's bigger or smaller than the other, right? Okay. Next, this significance level alpha. Well, that's given to us in the question. I wrote it down to be 0.05. So that was easy. We have to calculate the confidence level though. Does someone remember the equation for the confidence level? It's on the back page. For the page behind yours. It's in the list of steps. Yeah, it's 100 times 1 minus alpha, right? So in that step, this is the formula you have to know. We'll be using it for a while, so you'll get used to it. Okay, so this is 100 times 1 minus 0.05. Okay, personally, I like to subtract first, then multiply. So 1 minus 0.05 is 0.95. And if I hit that with 100, we get 95% as our confidence level. All right. We have done all the work to set this problem up. The next step for us is actually to go on Minitab, okay? Now, if you want to follow along with the steps, I'm actually going to follow all the steps on step 4 here. I'll walk you through it here so you can see exactly what I'm clicking. But that's kind of what I'm going to do now. Okay, so let's go to Minitab. Oh my goodness. Okay, here we go. Okay, so starting at step number 4, the first thing I need to do is click on stat. So stat is all the way up here, okay? Click on stat. We're going to click on basic statistics. And under basic statistics, you'll see all these different tests, like 1 sample Z, 1 sample T, 2 paired T, or 2 sample T, paired T. These are all tests that we will eventually learn in the last 2 weeks of class, okay? They're all very similar. So we're going to start with 1 sample Z, and then you'll see later on, like, okay, there's other tests that we can do too. Okay, clicking on 1 sample Z. You'll get this box, okay? And the first thing you need to do is to tell Minitab that you're not like typing in the information on the columns. You're actually like just writing in all the data that's summarized in the question. So up here on the drop-down menu, we're going to click on summarize data because we're given a summary of the data, right? We're not given like, okay, like what's the, like, what are the actual raw data values, okay? Next, we're going to go to sample size. And well, it's good that I wrote this down, right? My sample size is 100 in this example, right? Okay. The sample mean is the sample mean I just wrote down, 70.3. The known standard deviation is the sigma, right? So it's what we know before we do the experiment. Sigma's 3. I'm going to click this little box that says perform hypothesis test just to tell Minitab, hey, we're doing a hypothesis test now. Hypothesized mean is what mu is, okay? So mu is like, okay, what is the mean that's given to us that we put in our null and alternate hypothesis? So 70 goes here. Now, at this point, it's very tempting to hit OK, but we haven't told Minitab if it's a less than, greater than, or not equal to test yet. We also didn't deal with the confidence level yet. So before you hit OK, you have to click on options, okay? And on the options, you have to type in the confidence level, okay? It was already typed in for me, but 95 is the value I found on my sheet, right? An alternative hypothesis tells Minitab if it's less than, greater than, or not equal to. Looking at my sheet, this is a greater than question, right? So greater than goes here. And now we're ready to hit OK and OK. Now, what pops up is a lot of information. We really don't care about all the information. The only thing we really care about is, well, it says p-value, right? That's what we want. The p-value here is 0.159, okay? So you don't really have to worry about all the rest of the stuff except what p is. All right. Any questions on Minitab? It's not that bad. I think it's just remembering like what to click. But honestly, that's a lot easier than going through and mathematically calculating these. I promise you it's a little bit easier. All right, let me share my screen again. The worst part about using Minitab is going back and forth with screen share.
Surely you just pull up my Surely you just pull up the tablet.
I never thought of that. That is so smart. I'm kind of.
You've never thought of that?
I didn't. I really did. I wish there's a Minitab app. That would be fun. Dang. Okay. That's true. I'm kind of. I don't know if I search anything embarrassing on Google on this thing, so I'm not gonna do it today. That's true. Oh, really?
You can use the background tab.
Okay, you know what? I'll do that next time. Okay, I'm scared because I don't want Yoshi saying something every 2 seconds or whatever. popping up on my iPad. All right. So this is what we get on Minitab. The p-value is 0.159 because it literally says p-value, right? Let's decide if we reject or fail to reject the null hypothesis. This is by, writing p and alpha next to each other, right? I personally like doing this. If you don't want to do it, then that's fine. But oh gosh, 0.159 goes here. Alpha is, well, I wrote it down here, 0.05. Okay, which one's bigger, P or alpha? P, right? Definitely looks a lot bigger. I didn't even have to write them next to each other, honestly. But since P is bigger than alpha, do we remember if we reject or fail to reject? Fail to reject, right? So if you get confused, just go to the second page of the notes and you'll see why. But we actually fail to reject here. Fail to reject HO. Okay. And now all we have to do is write down our conclusion. Okay. Personally, to me, I like just sticking with templates. I think it works the best and it helps us like write it the right way too. So I usually just piece together two parts of a sentence. Okay. The end part of the sentence, this has been a while, so I'll just tell you. The last part of the sentence is always the alternate hypothesis. No matter what happens, H1 is always at the end of our sentence, right? Now, if you wonder what H1 is, we wrote it down over here, right? Mu is greater than 70. So I'm just going to stick that right here. U is bigger than 70. Now, the beginning of the sentence actually depends on if you fail to reject or if you reject. So since we fail to reject, do you remember if we say we conclude or do we say not enough evidence to conclude? Not enough evidence to conclude, right? So we'll start by saying there is, I cannot spell, there is not enough evidence to conclude. I don't know why I always stick of that there, but to conclude that this is true. Okay, that's what our conclusion is. We don't have enough information to say that mu is greater than 70. We're not really accepting that mu is equal to 70, but we can't say that mu is greater than 70. All right. Any questions on this problem here? All right. So how about this? If you go to the next page, we have a very similar example. I at least want you to try parsing through the sentence or the paragraph. Try to see what you can get down. If you do that in time, then by all means keep going. But I'm gonna give you like, I don't know, maybe like 3 to 4 minutes to at least start this problem, and then we'll come back. So you guys are just speeding through. All right, well, we'll start going over this one. Just because I want to show you what to do on Minitab just one more time so you're used to seeing it. Okay, so we have a large company, right? We have a bunch of information that I really don't care about with standardized tests and all that stuff. Okay, the mean score over all the company's employees was 74. Now, is 74, is that the population mean or the sample mean? Population mean, right? First of all, we haven't talked about a sample yet, right? So it doesn't make sense to talk about the sample mean if we don't have a sample. Also, it's over all the company's employees, right? So we didn't go ahead and sample everyone, right? So mu has to be 74. Okay, with a standard deviation, ooh, it literally tells us the symbol. That's so nice. Sigma equals 8, right? Okay, so under this telecommuting process, workers could spend 1 day, blah, blah, blah. Now we're taking a random sample of 80 workers. Oh, goodness. I did this in my last class, too. All right. Do we all agree that N is 80 here? Cool. All right. They took the test. The sample mean was 76. Did we get the X bar with 76? Nice. And then the standard deviation is 8. I already wrote that down, so I'm not going to write that down again. Can we conclude that the mean is different at the alpha equals 0.05 level? Okay, so I wrote down all my information. Now I don't really have to go up and down when I'm looking at numbers when I do this problem. All right, assumptions, pretty easy. We've done this before. Sigma is given to us, right? Sigma is 8. Sigma is given. Is my sample size bigger than 30? Yeah, right? 80 is bigger than 30. We are good. This is the same stuff that we've been doing over and over again. We don't have to worry about that. Step 2 is stating the null and alternate hypotheses. I think I actually saw a lot of you do this, so I'm going to just go over them and we can kind of just follow along. The null hypothesis is H0, right? Okay, we put a colon after it, and we always talk about the mu equaling a number. What number is it? 74, right? It's really useful to write down all our information up top because it's there. I don't have to go back in the problem. I know what mu is, right? It's equal to 74. H1 is the alternative hypothesis or alternate hypothesis. Everything's the same except that we're not going to have an equal sign. We're going to have like a less than, greater than, not equal to sign. And just a reminder that the last sentence is usually like the biggest hint as to what it is. It usually tells you like what we're trying to figure out, okay? So it says, can we conclude that the mean is different since the policy change at this level, okay? What are we thinking? Greater than, less than, not equal to? Not equal to, right? Now, the biggest hint here, if it's not equal to, is there's nothing that says higher than, lower than, greater than, less than, wider than, narrower than, anything like that. If there's nothing that tells you like if it's bigger or smaller, not equals is the place to go, okay? All right. We wrote our null hypothesis, we wrote our alternate hypothesis. Now we have to do step 3. The significance level alpha is equal to 0.05. I wrote it up here. So actually finding the confidence level is the same thing we did in the last section, right? Or the last question. It's 100 times 1 minus alpha, right? We can substitute it in. And since I literally did the same calculation in the last page, I'm just going to tell you it's 95, right? Same thing that we did before. Okay. Any questions before I go to Minitab? Oh. All right. We're going to do this. We'll do this one last time. And then after that, I will try using my iPad to use Minitab. Okay. So we're going to click on, what is it? Is it stat or calc? I don't remember. I haven't done this in a while. Okay. I haven't taught this class for like a good, well, I didn't teach it last. No, I did teach it last semester. I just haven't done this for a while. All right. Stat, we'll go to basic statistics. And then up here, we'll see all the different tests that we'll learn about. So the first one we're learning about, one sample Z test, involves questions like these. So I'll click that. Okay. Wish this would go away. There we go. Now it's kind of already defaulted to what I had before, so I don't have to change it to summarize data since it's already there. The sample size I do have to change, right? It's now 80. The sample mean is 76 now. The known standard deviation is now 8. I'm still clicking the box, but now the hypothesized mean, or the mean in my hypothesis, is 74, okay? Really tempting to hit okay at this point, but we have to click options first. First of all, to tell Minitab what the confidence level is, which is 95, but also to tell us what the alternative hypothesis is, right? So not equal to is what I'm clicking now, okay? And you actually do get different results based on what that is, so be careful when you're selecting this. Okay, hit okay, hit okay. And we get a bunch of information, but honestly, what really matters is the p-value here, 0.025. Okay. If you remember from your lab, actually, it also tells you what the confidence interval is too. But we only care about the p-value. Okay. Any questions on Minitab? Cool. All right. So let's go back to the screen. Hopefully this is the last time I will do this ever. All right, going back. And this is what we got on Minitab, 0.025. Personally, I like to write P and alpha right next to each other because, well, that's what I like to do, right? P is 0.025. Alpha is equal to, well, we have to go to the back page for that, right? 0.05. Which one's bigger, P or alpha? Alpha, right? Yeah. So P is less than or equal to alpha. Do we reject or fail to reject? Reject, perfect. So we reject the null hypothesis. Okay. Finally, we have to write out our conclusion, right? So we're piecing together 2 parts of a sentence. Does anyone remember what always goes at the end of the sentence? H0, H1. H1. No matter what question it is, it's always H1 at the end. So we're going to peek back. H1 is mu is not equal to 74. I'll write that down. Okay, the beginning depends on if we reject or fail to reject. So since we reject the null hypothesis, okay, are we starting with we conclude or not enough evidence to conclude? Do we remember? It's actually we conclude. Okay, so if you reject the null hypothesis, start with we conclude. I always stick like a little that. I don't know why. We conclude that. And if you fail to reject, you say, well, there's not enough evidence to conclude. Okay, so our conclusion now is I can actually conclude that the mean what is it? Like score is not equal to 74. I've made that conclusion. Okay. All right, any questions on hypothesis testing? Does it kind of like feel a little bit better now based on the last section? I think like once you start putting it together, it just becomes a little bit easier because you're just doing like little steps. They're not hard by themselves, but all together, it kind of is tricky to see what to do on each step. All right, there's only one last thing I want to talk about, and it's about alpha. Okay, now I talked to you about this level alpha, which I said was the significance level. Now alpha is kind of just given to us in the problem. I didn't really talk about like what it was aside from like it. There's a formula for the confidence level and it's in there. Okay, basically what alpha is if you remember from last Monday, we talked about errors, right? Now, when I make a conclusion in a hypothesis test, I actually don't know if my conclusion is correct or if it's incorrect, right? So basically, I can make a mistake. There's two types of mistakes you can make. Type 1 is like when you reject something that's true, and type 2 is when you fail to reject something that's false. But anyways, alpha is actually the probability that you make a type 1 error, okay? Which is why it's always pretty small, right? Alpha is equal to 0.05 in the last two examples. A small alpha is good because that means we're not going to make a type 1 error, okay? Now the question is, well, we don't want to make a type 1 error. Why don't we make alpha like 0.00000001, right? That would be great because we won't make a type 1 error. Anyone want to hint as to what the problem with that might be? Okay, this is the type 1 error, right? If the probability of a type 1 error goes down, well, we have a type 2 error, right? If the probability of type 1 goes down, the probability of a type 2 error goes up, okay? So there is this very fine balance you have to play. We can't make alpha super small because even though we would have a very low probability of making a type 1 error, the probability of a type 2 error is going to shoot up, okay? So that's why the significance level is usually like around 0.05, 0.01, usually nothing other than that. We're not going to make it like 50 or 0.000001, right? Okay. All right. Well, that's pretty much all I have for you today. So how about this? On next Monday, we'll talk about same thing, but with a different type of question. And have a happy Thanksgiving.